The oscilloscope I ordered has finally arrived. Which manufacturer did I order this from? It's Teledyne LaCroix. Let's open the box. The box is huge. Inside, there's another box. There are papers and probes in the box. The probes are passive probes. And here, can you see? The oscilloscope is in here. I'll remove the cushioning. They put a large cushioning to secure the oscilloscope. This is the oscilloscope I purchased. HDO6000B series by Teledyne LaCroix. Let's remove the cover. The model number is written here. Insert the power cable on the backside, then turn the power on. When I ordered this oscilloscope this summer, they said the delivery date will be at the end of the year or January next year. But actually, it arrived in early December. This is the oscilloscope I've been using, just a normal oscilloscope with BNC connectors. This one is more than enough for hobby use. But recently I often make professional measurements, which requires active probes. That's why I decided to introduce an oscilloscope for professional use. Active probes are very difficult to use with oscilloscopes with BNC connectors, because you need to secure a power source for the active probes. However, in the case of this new oscilloscope, look, next to the connectors, there are power sources for active probes. You can make measurements without securing power sources. I bought active probes as well. These are the active probes, 2 current probes and 2 differential probes. 4 probes in total. I turned on the oscilloscope and it's ready to measure. Let's connect the probes. Waves appeared. It seems the trimmer capacitor isn't adjusted. You can adjust the trimmer capacitor by turning it. There you are. I bought a 1 GHz oscilloscope, released by Teledyne LaCroix HD6010B. I'm going to tell you why I chose this oscilloscope. What I like most about this HD6000 series oscilloscope is that you can operate it very easily. As you can see, you can switch the waveforms very easily. I chose this oscilloscope because personally, it was the easiest to operate. The UI of oscilloscopes varies a lot depending on their manufacturers. In my opinion, how easily you can operate an oscilloscope is the matter of how long you've been using it, but for me personally, this oscilloscope is the easiest to use. I'm not saying others are not good. I bought Teledyne LaCroix's oscilloscope, but I had 3 other candidate manufacturers. One was Yokogawa Electric Corporation, a Japanese company. Another was Tektronix. I suppose Tektronix is the most popular oscilloscope manufacturer. The last was Keysight. Honestly, oscilloscopes of this price range have little difference in specs between manufacturers. Therefore, I chose the one that's easiest to operate, which was Teledyne LaCroix. Teledyne LaCroix manufactures many other models. I'd like to explain why I chose this model. Actually, I had 3 candidates: Wavesurfer 4000, HDO4000A, and HDO6000B, which I chose. I compared the screen size between those models. This one has a 15.6-inch screen. It's big. First thing I was concerned about was whether the screen fits in the angle of view when I take a video. However, despite my concerns, as you can see, this 15.6-inch screen easily fits in. So the size is fine. I also compared the smoothness of the response. When you touch the screen and move objects, the motion delays on every oscilloscope. Wavesurfer 4000 had a large delay. On the other hand, HDF4000 series and HDO6000 series, which I purchased, were very quick to respond. I was able to operate them very easily. How smoothly you can operate an oscilloscope is pretty important. When using this oscilloscope, I don't get stressed. Next, I compared the weight. Weight is also important for me. I often bring an oscilloscope back and forth from the working space to the shooting space. It's tiring to do that if the oscilloscope is heavy, so I decided to include in the selection criteria that the oscilloscope must weigh 10 kilograms or less. This one is less than 10 kilograms, so it meets the criteria, but barely. It's almost 10 kilograms, but it meets the criteria anyway, and when I actually carry it, it doesn't feel so heavy. No problem. Next, I considered how fast the oscilloscope turns on. It's stressful when it takes long to turn on, so I chose a model that turns on fast. There were comments on the previous video to ask if there's any merit in using an oscilloscope that turns on fast, even if you must warm it up before making an accurate measurement. There are merits. For example, I think you guys sometimes want to see the voltage waveform of particular points quickly. In such cases, if you have an oscilloscope that turns on fast, you can quickly check the approximate shape of the waves. For me, it's very important that I can quickly check the waveforms because, honestly, I can't wait until the warm-up finishes. Of course, waveforms displayed after a warm-up are more accurate, but in the first place, in my videos, there's no situation where whether a warm-up was conducted or not heavily affects the whole results of the experiment. Therefore, for me, it's very beneficial that the oscilloscope turns on quickly. Next, I'd like to tell you about the frequency band of this oscilloscope. I heard from the sales engineer of Teledyne LaCroix that HDO6000 series models are equipped with different chips according to the grade of the frequency band. So, If you want to upgrade to a better frequency band, you'll have to replace the circuit board. Other Teledyne LaCroix oscilloscopes have software limitations for lower-grade models. In order to upgrade the frequency band, you only need to remove the limit. However, this 6000B series isn't that flexible. You need to pay for replacing the circuit board as well. So I decided to purchase the 1 GHz model, the highest frequency band. Next, I considered the mixed signal option. There are 4 analog inputs here. It's common for an oscilloscope to have only analog inputs, but some oscilloscopes have digital inputs here as well. The model I purchased has an option to install digital inputs. I've been using an oscilloscope here for a while, and I mostly use these analog inputs. I've never used digital inputs. Since I've never used them before, I suppose I won't use them in the future. So I decided not to add that option. If I ever need to measure digital signals, I'll borrow a demo machine from Teledyne LaCroix. Next, I considered the specs of the probes. I bought differential probes as well as the oscilloscope. To be honest, passive probes that come with oscilloscopes are not so different between manufacturers. In the case of LaCroix, 1 GHz model comes with 500 MHz passive probes. These are the probes. It says they are 500 MHz probes, but I doubt it. Alligator ground leads are attached, so to be honest, I suppose it's very hard to measure 500 MHz with these probes. I think you'll need to remove the lid and attach some attachments at the tip to measure 500 MHz. If you want to measure signals with even higher frequency, you'll need to use active probes. And the specs of the active probes are important. Of course, the specs of an oscilloscope is important, but the specs of the probes to use with it are also important, which is obvious because you can't measure signals without a probe. Passive probes can be connected to any oscilloscopes from any manufacturer. But these active probes that I bought cannot be connected to oscilloscopes from other manufacturers. It's because this box-shaped thingy specially made for LaCroix processes something here. So I recommend checking whether an oscilloscope manufacturer has a probe that you want to use. I mainly use high-voltage differential probes and current probes. Tektronix probably has the richest variety of such probes. Next comes LaCroix, followed by Keysight. But I chose LaCroix because the specs of the active probes I wanted to use were not so different between Tektronix and LaCroix, and I prefer LaCroix's usability. You can measure a lot wider range of signals if you have active probes. I chose these high voltage differential probes. The maximum voltage is 1.5 kV, and the bandwidth is 120 MHz. These are current probes, clamp-on type. These are CP031 models. The effective value is 30 ampere. They are Hall effect probes, so they can measure both AC and DC. You can measure the signals by clamping a cable here at the tip of the probe. This part is made by Hioki Denki. They make this part for many manufacturers' probes. This active probe doesn't need external power supplies. You can use them just by plugging them in here. I used to use differential probes and current probes that come with external power supplies, like this one. You need an outlet to use the power supply. Also, there will be too many cables. To be honest, it's really inconvenient. That's why this time I chose active probes that take power from the oscilloscope. They are a lot more convenient. Let's actually measure something with this current probe. Clamp the cable here. Let's have a look at the waveform under CC mode today. I turned on the CC mode. Current appears on the display. I set the maximum to 10 ampere. But on the specifications, the probe withstands 30 ampere. The vertical axis of the oscilloscope shows the current value. This is the same for other manufacturers, but it's convenient that it automatically shows the current value. By the way, it cost several million yen to purchase the oscilloscope and probes. It was a really expensive purchase for YouTube videos. Today's video was about the Teledyne LaCroix oscilloscope I purchased. You can use it for 4 to 5 years. I'll have it calibrated from time to time. If LaCroix releases a new oscilloscope, I want to try it as well. Thank you for watching.